So let's look at number 15 in your notes. So let's start with this image. When a football player kicks the ball, it heads off with a velocity, and that's this green arrow right here. You notice the velocity is getting shorter and shorter until up here, the velocity is the exact as the x velocity. It then increases and increases again as it goes along. So we'll call this the number 1, the number 2, 3, 4, and the 5th position. So the overall motion is that it slows down, and when it gets to the top, it's still moving at the top, and that's very important. But then after it peaks, it comes back down and gains velocity. I've drawn the velocity vectors a little differently. We're used to seeing it over in the x, up in the y. This time I moved the y, which is this guy right here, to here, so that you could see the x and the y components. I prefer the triangle, but some people see it better this way. Now, what's important is the x length is the exact same all the way through. The x velocity does not change. So what we've got is a constant velocity situation with the x. At the very top, the velocity in the y direction is 0. Therefore, the velocity equals the velocity in the x. As we come down here, these velocity vectors, so if I wanted to know what this value would be, it's Pythagorean theorem. Let's look at the y velocity vectors. This one's rather long, and then it gets short, and then there's nothing up here at 3. Then it gets longer again, and even longer. The length of this one right here at 2 and this one right here at 4 is the exact same. The only difference is they're pointed in different directions. Same goes for this first position and this 5th position. The velocity vectors are the same for these two in the y direction. They're also the same overall, they're just pointed differently. So if we were to describe the overall motion, the ball rises and forms a parabola, comes back down. At the very top, it's moving the slowest, and then it picks speed as it comes back down. The Vx and the V at position 3, that's the very top, they are equal to each other. The Vy at position 3 is 0. There is no velocity in the y direction. Please note, there is acceleration in the y direction. There's constant acceleration in the y direction, and that is gravity. Now, what is true of the y at position 2 and 4? They're equal, and they're opposite sign. One is up, one is down. Now, just to look a little bit more closely, this is how we've been drawing the triangles, and this is fine. We can keep doing it this way. What I did on the program I made this on was grab this y and just move it over here. So here's the ball being kicked. Here's its velocity, this main arrow here. Its x component's here, its y component is there. You can visualize it either way, it works. The only caveat would be is if you are trying to get the angle or trying to get the velocities here, you need to be careful about which angle you use. So if you were doing the velocity in the y, you could say that is the velocity sine 42, or you could say the velocity in the y is the velocity cosine 48. Be very careful about which one you use and the angles you're using. You just want to make sure you're getting the x and the y. So let's do an example. And I'm going to skip this one, and I'm going to look at this baseball. A baseball is thrown at an angle of 25 degrees relative to the ground at a speed of 23 meters per second. So let's draw that. So 25 degrees, speed is 23 meters per second. If the ball was caught 42 meters away from the thrower, how long was it in the air and how high did it go? So, a couple of things. It didn't say that anything, but we're going to assume that the catcher and the thrower are catching and throwing from the same height. Let's make a X and a Y column. And the first thing I'm going to do is get the velocity in the X and the velocity in the Y, because that's what we have to use in all of our equations. We cannot use that 23. So I know that, let's draw this a little bit bigger, 23, maybe a little bit better, but I know that the sine of theta is equal to velocity in the Y over the velocity. So the sine of 25 is equal to the velocity in the Y over 23. So 23 sine 25 is the velocity in the Y. Let's do the X. So the cosine of theta will equal the Vx over the V. So the cosine of 25 will equal the Vx over 23. 23 cosine 25 equals Vx. So let's calculate that. 20.8 meters per second is the Vx. 9.72 meters per second is the Vy. Okay, so I've calculated something. Let's get some more information. I know that dx is 42 meters. I know the acceleration in the y is negative 9.8 meters per second squared. And that's all I really know. And I know that time is universal. It works in both. So the question is, how am I going to get the time? I have enough information that I could get it from the y. I also, strangely enough, have enough information I could get it in the x. So I'm going to go ahead and get it in the x because it looks a little easier. So velocity in the x is equal to the displacement in the x over time. 20.8 equals 42 divided by time. So time is 42 divided by 20.8. So 2.02 seconds. So that's how long the ball is in the air. So we have 2.02 seconds. Well, that means I can use it with this information to get the total height. Now, a couple of things. There's a bunch of different ways to do this. But what we're looking for, rather, not the total height, is the max height. The max height occurs at the halfway point. So if I wanted to use the time, I could cut that time in half because it took 1.01 seconds to get there. Or I also know that at the max height, the velocity in the y direction is 0. So I could actually use that Vf squared. So I think that I'll use that one. So let's see, Vf squared equals Vi squared plus 2AD. And this is all y stuff, right? Everything is y. So 0 equals 9.72 squared plus 2 times negative 9.8 times d. So it reached a height of 4.82 meters, and it is positive. That should make sense because it's above the ground. How long was it in the air? I got the total time using the x information. I could have used the y information. And then how high did it go? That was all about the y. I didn't even have to use the time. I could have, but I chose not to. So let's look at projectile motion problems. Let's look at number 18. It's a soccer kick. It's kicked at an angle of 37 degrees with a velocity of 20 meters per second. That means its actual velocity, as shown here, is 20 meters per second, and there's its angle. What we need to do first, before we even kind of dig into this, is figure out its x and its y velocity. So let's go over here, and let's look at its x, and let's look at its y. So the velocity in the x, let's draw a triangle. 37 degrees. So we'll go with 3 sig figs for the velocity in the x and the velocity in the y, make our lives a little easier. Okay, so we've got the velocities in the x and the y. What else do we know? That's all we know, except we do know the acceleration is negative 9.8 meters per second squared. That's important. That's really all we know. So A, find the max height reached by the ball. We know the velocity in the y at the max height is 0 meters per second, so that's something to know. And so let's see. Using the equations, I think VF squared equals VI squared plus 2AD works the best. 0 equals 12 squared plus 2 times negative 9.8 D. So then negative 144 is equal to negative 19.6 D. So 7.35 meters above the ground. So find the time the ball travels before it hits the ground. And that we can let's ignore this. So that's the whole parabola. And so what we know about that situation is the D and the Y is 0 meters because it started at this level and it ended at this level. So it has made no displacement overall. So let's see. Probably the D equals VIT plus 1/2 AT squared. Now this is all Y stuff. Put my Y's in here. 0 equals velocity in the y, which is 12 times time plus 1/2 negative 9.8 t squared. So 2.45 seconds. And that is the time, the total time of the movement. If we wanted to get to the halfway point, we would just cut that time in half. So 2.45 divided by 2, 1, 2, 1, 2, 3. You know, it did have that second question. So then let's see what C says. C asks the horizontal range of the ball. So it wants this dx. Well, we have the Vx. We're looking for dx, and we do have time. So 16 equals dx divided by 2.45. So remember, this is the only equation we can use in the x direction. So 39.2 meters is the dx. Determine the velocity of the max height. Well, at the max height, we know the vy is 0. And the velocity, the v, equals the vx. So d, the velocity equals the vx, which is 16.0 meters per second. So that's the answer to D. What's the velocity just before it hits the ground? Well, it went up at 20, so the velocity, yep. And then if we were to look at the angle, so the x would still be 16 in the forward, the y would now be 12 down, and when we get this angle, it's roughly 37 degrees south of east. So notice it's the exact same as before, it's just the direction is different. So same magnitude, same angle, just the direction. And if you don't have that negative there, that's fine. You just have to know that that the y component is negative. That's the important part. Okay, find the vertical velocity of the ball at a height of 3 meters above the ground. So you're looking for a velocity at 3 meters above the ground. So probably looking at this equation, because it's got a height, it's got initial velocity, and it's got a final velocity. So we can put that 3 in here. So we're looking for this velocity final squared. This is 12 squared. Remember, this is the y direction. Plus 2 times negative 9.8. Rather, the d is 3. So the velocity final squared is 85.2, and the velocity final, and this is in the y, is 9.23 meters per second. So at 3 meters above the ground, that is the velocity in the y. Now, that's on the up. On the other side, same level, down, it's negative 9.23 meters per second. And then G says find the velocity. So it's asking for that total velocity. So for G, what we're looking at, and it said the first one, so we'll use the first one. We know that the Vy is 9.23. The Vx is 16 meters per second. We know that because it is constant. It is not changing. It's always going to be 16. It wants us to find the velocity. So this is the Pythagorean theorem. So V squared equals 16 squared plus 9.23 squared. Let's say it's like 341.1, and then the velocity is 18.5 meters per second. It's very important that you note that it's not above 20. If you get something above 20, you're wrong. Can't get any faster because gravity is slowing it down. So let's find theta. The tan of theta is equal to 9.23 over 16. Therefore, theta is roughly, it's close, 30 degrees. And according to my drawing, it is north of east. And this is for that first one. If it asked for the second one, it would be 30 degrees. But in this case, it would be south of east because it would be below the horizontal. And the way you look at that is 9.23 down while it's still going 16 over.